All right, ladies and gentlemen, we have seen the requirements for precision. We have moved forward into a design phase, and we have designed the game. Now it is time for us to begin the implementation phase. Now, as I've said back in the beginning of this chapter of videos, we are not going to have a single implementation plan video for the simple fact that precision is a very large project. Okay, it's not a very large project, but it's large compared to everything we've done so far. And we're really not wanting to get bogged down with a very long implementation video and then jump into hours of coding. So we're going to break it all up to keep everything very clear and concise. So this video is going to be an overview of the entire implementation plan for precision. But first, so far, all we have seen has just been, what, some graphics. We've said precision is going to be a screen, it's going to have some cells on it, and you're going to have a little nanite dude that's going to run around, and you're going to have some antibodies, and they're going to be moving around, and you're going to try to be dodging them and saving, and there's health bars, and that's all you've seen. You don't know what precision actually looks like. I mean, I'm sure everybody that's viewing the video right now has some sort of mental picture, but it might not be a bad idea to show you what we've got in mind. So let's take a quick look at precision in our image, the way we've put it together.
All right. Let me load up this folder that has a version of the game in it.
Dun, dun, dun. Okay, isn't it great? The games that we're going to create, we start out with these really simple games. So, of course, Precision was the original game, the very first game planned for the XNA Xtreme class. And now, of course, it ends up being like 5 games later or so. But here it is with this spectacular-looking graphic, but it's still going to be a very simple 2D, casual, top-down type game. And yeah, the graphics are so misleading. It really reminds me of some of the old school games that used to come out where you'd look at the box art, right? You're standing there in EB Games or whatever, and you're like, wow, this is so awesome. And you get home, and it's just not as awesome as the graphics on the box look, or even the splash screens that would come up. So we've given the exact same treatment here. We've got a beautiful splash screen for precision, and you'll see it's letting the player know to press start to begin. So we'll go ahead and press start. And keep in mind, when we talked about the design phase, we introduced the idea of game states, and we started out at a title screen state, and if you hit start, we advance into a level change state because we are changing to level 1. So let's go ahead and hit start. So here we are. Not quite as exciting now. So this is where the graphics kind of take a step down. It's like, oh, it looked like it was going to be so next generation just a second ago. But here we are, about to begin level 1. We've got 2 cells that are going to be in this level, and we've got 1 antibody that will be in the level. Now, please keep in mind, as a cell begins to die, it will show a life bar, and its color will begin changing from green over to purple. As the life bar slowly dies away, it'll finally hit 0. That means the cell has died and has gone completely purple, and an antibody will be spawned from the center of it, and it will scale out. So at that point, if we lose 1 cell, we'll have 2 antibodies. Keep in mind how the scoring works. In the upper left-hand corner, you're going to see the value for each of the cells. And as we lose cells, which at first Logan will be able to simply hit the cells, it'll be no big deal. But as it becomes more and more involved, getting around the screen to save our cells because we've got to dodge the antibodies, keep an eye on what's happening with the score. You'll see the score, the value, start to lower for what we get for each cell that we save as cells die. So keep that in mind. So what I'm trying to point out is there's actually a lot of things going on. And of course, Logan wants to avoid the antibodies, and a level change occurs when there are no cells left to be saved. This means Logan could hide in the corner, all of the cells could die, and we'll go through a level change. But the idea of this game is to get as high of a score as possible. So by hiding in the corner, you're not getting any score. So you're completely, getting around the purpose of the game. So with that, Logan, let's go ahead and hit A and begin playing.
And keep in mind that everything that you've just described is now about to take place in about 3 seconds because level 1 is very short.
Yes, it is.
So here we go.
So there it is. We've got 1 antibody, 1 cell's dying, another cell's dying. Logan saved 1, the other one died, and we have advanced to level 2. Ooh, that was pretty simple. So here we are with level 2 about to begin. Once again, we are now at a level change game state. So we're sitting here at the screen looking at how many cells are about to be in this level and how many antibodies. So 4 cells, 2 antibodies. Press A. Okay, so here comes the 2 antibodies. 1 cell began dying, a second cell. Oh, there goes the third one, and Logan's going to save the 4th. Boom. And here we go. We've now advanced to the next level, sitting once again at the level change game state. And here we are. Level 3 is going to have 6 cells to be saved and 3 antibodies to start off with. Logan, this time around, let's go ahead and grab the time power up and demonstrate everything slowing down. Cells dying slows down. Antibodies spawning slows down. Even their scaling up. Everything's going to be slow with the exception of you. Okay?
All right, so spawning, waiting a second, and there's the time power up, so let's run over to that. All right, everything is slowed down. Cells dying more slowly.
Slow.
That enemy is spawning more slowly, and then the time effect expired.
Okay, and in this case, Logan saved very few cells, so he did not get many points. So let's go ahead and do the next level. So
now
once
let's
again,
go for the time power up again. So we're getting a cell, another cell.
See how they
cells.
die real slow now. And again, he's got a bar at the top indicating how much time he has remaining for the power-up. So there he goes as he threads his nanite probe through all of the antibodies like a needle. Like a thread through needle. There we go, and beautiful.
And now we get into a case where there's so many antibodies congregating around certain areas that you're kind of cut off from certain parts of the screen for a while. And yeah, not worth getting.
Okay, so let's go ahead and demonstrate 2 speeds. So there's fast.
Here's the normal speed, and then if I hit the B button, then I can move at this increased faster speed. So slow speed, and then fast speed.
And, whoa, and he just went through a died game state.
Let's go back to that for a second,
right.
then we can take a look at it.
So here we are. This is what we were talking about in the design phase, where when you die, basically it's going to be a red transparent overlay over the game. The game is paused in the background, and we've put a very simple message that has said, you died. Press A. So when he presses A, he's going to continue, but he starts from the center. Of course, that was the very end of the level. He started in the center. He was blinking, indicating that he was invincible for a second so that he can move out of the way of any antibodies so that he wouldn't die on spawn. Let's go ahead and advance. So here we go once again. He started out blinking just with every level change so that you have just a second to get out of the way of any antibodies that may be there. And it really starts to get important as you begin advancing into some of the upper levels, grabbing that time power-up. Time power-up is just so important. So we'll see how far Logan can take this.
Convenient time power-up spawn there.
No kidding. And very nice, very nice. Can really start to feel, why it's called precision after you really start getting a lot of antibodies on the screen because, well, you really need to be careful so you don't hit them. But there you go. That is a very quick look at precision. I mean, for the most part, it's a very easy game. But it's going to start drawing on everything that we have demonstrated throughout all of the 101 class. Okay? So let's go ahead, close this out. And we'll get that out of here. And now it's time to start focusing on the implementation plan. Now again, this plan is an overview. What we're going to do is we're going to take this project and we're going to break it up into 13 different parts. Now, each part will represent a minimum of 1 implementation plan and 1 video for coding. So that means you have 2 different videos for sure in each of these different parts. Some parts are quite a bit larger than others, and because of that, we may break it down into 1 implementation video and then 2 or 3 coding videos if need be. So I'm just throwing that out there right now. But like I said, 13 parts. So let's go ahead and focus on what we're doing in all of the 13 parts. So this really is the big picture. So we're going to start out. I'm going to try to abbreviate things as much as possible so I don't have to do too much writing. Part 1. What are we going to do in part 1? Well, we're going to start out by skeletoning in all of our classes with all of their members. We're going to leave methods empty. There are, in fact, a few methods that are even going to be left out because those methods pertain to a very specific functionality where we'll introduce all of the parts for that functionality at one time. Things like flicker and invincibility, but we'll talk about those later. Right now what we're doing is we're getting the skeleton for the base game, for everything that's involved in the base game in place. And skeletoning in things have worked out really well for us throughout the Xtreme class so far.
Right. What it does is it lets you get a very good idea of the big picture, what things are going to be available, and will also allow you to see all of the classes all at once. So that way it's not a slow procedure where you kind of get lost in trying to work your way through things. Instead, what it lets you do is not only lay down all of the classes, but since the members inside of those classes are defined, it means that you can actually start to build the functionality piece by piece. That way you're never stuck in a scenario where you have to implement 3 different classes at the same time before you can continue. If the members are defined, you can then begin using them even if they aren't fully fleshed out.
Exactly. Next thing we're going to do, part 2. Well, actually, before we advance to part 2, let's talk just a little bit more about what you just said. With getting everything in place so that we can have things call on other things, even though the functionality isn't there, and it really helps get that big picture. Please keep in mind, before we do that, we will have an implementation video where we're going to say, all right, what do we need? And we're going to draw that out on the whiteboard first, before we just start magically creating these different skeleton classes. So keep that in mind. Moving on to part 2. In part 2, what we're going to do is basically set up the game class requirements. So we're going to shift focus away from our custom classes that we've created. We're going to go back to the game class, and we're going to set up some of the common things that you're going to find in almost every game you're going to work with. We're going to set up the resolution. Since this is a 2D game that's going to require a sprite batch, we'll go ahead and set up the sprite batch. We'll go ahead and define the game states. We're not going to implement them, but we'll get them defined. And then we'll go ahead and use that sprite batch. We'll get the background drawing, just so that we feel like there's been some accomplishment in part 2.
Right, and thinking back to all of the games created thus far, and even some of the demo programs, there's always something that has to be added to the game class. Since the game class is meant to be as generic as possible, it doesn't have any of the specifics for any type of game. And so we've had to do things like add a sprite batch for drawing. Then we've even had to add things like texture fields to hold textures to feed to the sprite batch. So we're going to have a section dedicated on getting the game class itself set up to support the type of game that we're trying to create.
Exactly. With things like resolution, sprite batch, define game states, because those are going to become so important. And then, like I said, just kind of to finish it all off, our bonus, I'll make it a little plus, background drawing.
Right, because at that point we'll have all the necessary classes for drawing, though the game elements haven't been implemented yet. But what we could do is put down the background graphics, since at that point we have the sprite batch ready, so we could do at least that and get the background drawing.
You got it. And from there, we'll get to move into part 3. Now, in part 3, what we're going to do is we're going to shift focus away from the basic game class back over to our own classes. We're going to start with the actor class in part 3. We're going to implement actor drawing, flicker, and the animated scale functionality. So basically what we're going for is by the end of part 3, we're going to have a player graphic drawn on the screen, not controllable, just drawn. It's going to flicker in, and then it's going to be able to be scaled up and scaled down by the use of, I don't know, the A and B buttons on the Xbox 360 controller. So we'll be able to hold one button, it'll scale up, hold the other button, it'll scale down, just so that we can test out our scale functionality and see it working.
Right, because we had laid out certain things that the game elements have to do. We had said that there's going to be a scale effect both on enemies and cells, and that enemies will have the scale in effect and cells will have kind of a scale out effect. In addition to that, we're also going to have that player flicker upon reset, the invincibility flicker. And the way we're going to handle these are as features of the actor class. Now, of course, we'll have the actor class with some basic functionality defined from the skeleton, but we've left out the flicker and scale simply because those are almost like small subsystems within the actor class. And I didn't want to have that confuse any of the basic drawing. So the idea here is that we first start out with the basics. We just make an actor drawable and then show one in the scene. And then once we have the actor actually working, we can turn around and then add the necessary fields and methods to get the flicker functionality working, which we can test by simply hard coding in a set for the flicker, just so we can see it working. Then once that's done and complete, we can turn around one last time and add some more fields and methods so that we can implement scale functionality. And of course, once that's implemented, we'll turn around and test it as well. But since the scale is kind of an animated over time style effect, what's nice is to put in an actual button binding so you can activate the scale. It makes it easier for testing because then you can repeat the test over and over again while the game's running and not have to continually stop and rebuild to see the effect in place.
Right. So the A and B button. All right, very good. So with that all in place, we're then going to shift gears over to part 4. And finally, things will start to come to life here. In part 4, where I have managed to actually select everything, that's awesome. That's what happens when I hit hotkeys by accident on the Wacom tablet. In part 4, what we're going to do is start focusing on our player. We're going to actually create the player. And then we're going to set the player up so that it can be controlled by the controller, so we can actually move him around the screen. And we want to go ahead and implement the player blocking, the screen blocking, so that we don't have the ability to exit off the screen on any of the sides.
Right, this is going to involve things like putting a field into the game class so that we can keep a reference to the player. Basically, everything necessary to get the player class itself created. Of course, we're going to continue on after that into things like player control, which will handle some input from the controller, as well as screen blocking so that the player is contained within the screen.
Right. So controller input and screen blocking. Simple enough. All right. Once we have that all set up, what we're going to do is move into 5, and in 5, what we're going to do, part 5, we're going to shift our attention over to the enemy. So we are going to create a functioning enemy. We're going to have random spawning ability. We're going to have random moving ability, so random move ability. We're going to have the scale-in effect in place, and we're also going to make sure that before we get done with the whole thing, we're going to have an add enemies static method that will allow us to simply add enemies into the scene. Okay?
Right, this is, of course, it will begin at the skeleton version of the enemy class, the one created all the way back from part 1. But what we're going to do is take a look method by method and implement all of the functionality. And that's going to include things like all the spawning code. It's going to include the movement code, because of course there was a specific behavior. If you notice from the game running, you could see that the enemies they picked a random location and moved to it over time, and then they continued that process. So we need to get the code ready to have the enemies wander around the screen. And once that's in place, we want to make sure that we have the scale-in style effect, so that when an enemy is spawned, either at the very beginning of the level or later as more enemies spawn, we want to make sure we have that scale-in style effect for the enemy entry. And then, of course, once that's finished, once we have each individual enemy working, it would be nice to have a method that would let us create an entire field worth of enemies. Because we know from looking at the level change screen that there's supposed to be a specific number of enemies on start, and often that's a lot of enemies. So what we want is a method that can take in a number of enemies and simply handles placing them randomly throughout the screen.
Right. So create add enemies static method. All right, so at this point, we've got some basics set up. We've got a background drawing. We've got a player drawing. The player has the ability to be moved around the screen thanks to the controller. We have enemies. These enemies are scaling in, moving around, wandering. We can control how many. Of course, the player is going to run right through the enemies because we're not yet doing any sort of player-enemy interaction, which just leads us to our next part. So let's go ahead and bring up another white screen real quick. Try to keep everything focused as well as possible. So here we are with part 6. And in part 6, like I said, we're going to focus on player-enemy interaction. What we're going to do is we're going to implement collision check-in. We're going to put player death into place. Now, of course, right now we don't have any game rules or anything going on. So a player dying doesn't mean we lose a health, we lose a player life, and the game could be over. All that'll come later. But we do have the ability to die, which means we need the ability to have the player reset so that we blink for a second in the middle of the screen, and boom, there we are. We can start moving around again. And, well, if we collide with another antibody, we'll die again. So we'll get all that in place in part 6.
Right, because leading into this lesson, what we have leading up to it is the usable player, a player that can be controlled to move around, and we have enemies running around on the screen. But the two don't interact. That means the player can run right through the enemies and nothing happens. So what this part's going to focus on is taking both the enemies and player into account and setting them up so that we can detect when a player-enemy collision occurs and then what should happen. This is going to involve adding some functionality to player so that we can do the reset style respawn, where the player gets moved to the center of the screen and begins flickering with invincibility, as well as taking into account some more details, meaning make sure that the invincibility actually makes the player unable to die again. in order to accomplish the collision check.
Because that is kind of important.
Right, so that means we'll need to do, it will begin as a simple collision check, but we'll have to add more considerations in. Like, is the player actually invincible? Is the enemy harmful yet? And things like that.
Exactly. Okay, so once we've got part 6, then we'll move over to part 7. So let's go ahead and jot that down. And inside of part 7, what we're going to do is create fully functioning cells. So we're going to shift our attention away from the player and away from the enemies because we've got a lot of that set up now and a lot of it working. So with the cells, what we'll do is we'll go ahead and get cells spawning in. We'll make sure to avoid cells overlapping one another. We'll go ahead and set up for cell death. Of course, at this point in time, we don't have any of the bar class in place, so we don't have the ability to have life bars show up, but we can, of course, control the tinting as they go from green to purple. We'll make sure that enemy spawns from a cell death, so as a cell dies, it's dead, and here comes an enemy out of it. And, of course, what we need to do is make sure that we check for player contact so that a player can save a cell that's dying by simply coming into contact with the cell. So we'll get all of that set up in Part 7.
Right. Beginning with the spawning, what that's actually going to be is a method similar to the enemies add enemies style method. That is, once we have a cell working where it can display on the screen, it would be useful to have a utility style method so that many cells could be placed randomly throughout the screen with a single call. So that will be accomplished in spawning. Just randomly create a field of cells. And
avoid overlapping. That's a big one.
Yeah, well, you'll see right after we get the spawning set up, we can up the number of cells that get spawned, and you'll notice that very often cells will overlap, sometimes almost to the point where they completely cover each other. So what we want to do is come up with some method of detecting when a cell is colliding with any other cells. And if that cell is indeed colliding, we want to try to place it somewhere else. So we'll actually need a control system so that we can attempt to place the cell over and over again, but avoid the possibility of an infinite loop in case a cell simply can't be placed. If there's so many cells on the screen that there is no free spot, we don't want the game to lock up in that case.
Right.
So we both need to do some checking, but be careful not to get into an infinite loop scenario.
Exactly. So
okay. Once we've got that, we'll have cells properly placed on the screen, and we can turn our attention to the cells dying. This is actually going to involve a little bit of work back and forth between the cell class and the game class, as now the game class inside of Update is going to have to drive some aspects of the cells, so that cells can both be attacked, and then once an allotment of time passes, the cells will actually die. And during that time, we need to see that fade style effect, where the cell goes from its healthy color to its dead color. And that'll take care of the cell death. After that, we can take that one step further and go into the enemy spawning, since the idea is that every time a cell dies, an enemy spawns from that cell's location, as though the enemy spawned out of the cell.
Exactly.
So we need to take a look at that and any considerations about how enemies spawn. But I'll leave the specifics until we get to that point.
Okay, and then of course we really need to make sure that we account for player coming into contact with cells that are in the process of dying so that we can save the cell.
Right. And what you just said is important there, because it's not just a collision check, but it's a collision check and make sure that the cell is in the right state, because a cell can only be saved if it is attacked.
That's right.
Going into contact with any of the other cells does nothing. They simply remain until they're attacked. And then you have the possibility to save them.
Exactly. Once we have all of that in place, now it's really going to start to feel like we've got the whole game jamming along nicely. We're going to move over into Part 8, and in Part 8 we're going to focus on the bar class. So we're going to implement a bar class, and then with that bar class we're going to turn around and use the new bar class for giving dying cells a life bar.
Right, we're going to begin with a bar class by itself so that we create a convenient class that gives a progress bar style drawing ability. It'll be a simple rectangular thin bar that can be given a specific width and height, and then in addition to its dimensions has a percentage. That percentage allows it to draw a percentage of its given width. For example, if the bar was set to have a width of 100 pixels, but then was set to have a percentage of 30, we'd actually see it only 30 pixels wide. The idea is that we can give the same idea as a progress bar and have some type of metering device which we can have count down, so you can see a bar on screen actually get smaller and run out, and that will create the life bar for the cells. Once we have that class, of course, we can turn around and give a life bar to the cells by using that bar class and simply tying in its percentage with the bar or with the cell's own health.
Right. Now, we're going to take a look at 9, and this is where we're going to need a little bit more room to write. So let's go ahead and just jump back up here. So in part 9, a lot of stuff's in place. So what we need to do now is start focusing on our screen so that we can start getting game states coming along. So what we're going to do is we're going to make all of our screens available. We're going to take a look at the title screen, the level change screen, the death screen, and the game over screen. We're just going to get it all set up. And then we're going to start on game states. And this is, we're not going to finish it. By the end of the next part, part 10, we'll have game states fully functioning, and you'll be able to change through all of these different screens. But we will, before leaving out of part 9, we'll go ahead and implement the start button so that we start off at the title screen, and then we can just hit start and begin playing.
Right. The idea here is that before we get into game states, we actually create these screen drawing methods. That way, when we do start dealing with state changes, we have something to display.
Right.
So we'll start by creating the screens. Now, of course, we'll do a simple test where we go into some debug state or or even the playing state and just test the methods one by one, so that we'll actually see them before we end up using them. But the idea here is to make all of the different state screens available and get them tested so that we're happy with the way they're looking. And of course, that'll include the title screen, the level change screen, and
we've got a death screen.
So we need to get the death screen in place. Depending on what's available, we may or may not be able to test the transparency, though rest assured it will be added in as part of this.
All right. And then finally, of course, a game over screen.
And that will give all of the screens that we need, because each of those screens will represent 4 different states, where the 5th state isn't technically a screen, it's just the gameplay in action without a screen.
Right. So start on. So here we are, we're going to start on game states.
And what that means is some of those might be immediately apparent, meaning some of the game states will do only one thing. For example, the title state is only going to show the title screen. It doesn't do anything else. So what we might do is drop in the actual title screen into the title state. So we'll get some of the state code out of the way in some of the more simple cases. We could even go so far as to make it so that we can advance from the title screen just to show an actual state change, though I don't think we'll do it all the way. Instead, what might happen is we could have the title state along with its title screen, but have it set up so that when you hit start, the gameplay begins immediately, since we don't have the level change logic in place yet.
Which is what I'm throwing right here. Advanced title to playing.
And that way we'll have all of the screens available to us, and we'll even look at some of the states and how we can advance from one state to another.
Which will allow us to move right into Part 10, where in Part 10 what we're going to do is we're going to implement the lives and levels. This is really important so that we can get level changing in place. We can have the ability to die, game over, which this, of course, is going to allow us to finish off all of the game states so that by the end of Part 10, we've got lives working, levels advancing, the ability to start out with a title screen, advance to a level change screen, advance to playing, die, repeat, die, and then finally game over, and then back to a title screen.
Right. Lives will give us what we need in order to calculate whether we've gone into a died or a game over state. And the level code will allow us to calculate how level beginning should actually work, so that the level changing actually influences the enemies and the number of cells. Then once all of this code is in place for lives and level, we can now put all of the states into full effect. That means we get the what do you want to call it, the state flow chart can be filled out, if you will, where we have the title screen properly advancing to the level change screen and then on to gameplay. So all cases can now be accounted for, so that the gameplay state can go back to dying, which can go back to the title, or you could successfully complete a level which would go back to level change. So we'll make sure that that both the lives and level code is in place, as well as all of the game states. And once those are working, we do need to take a look at levels specifically and make sure that they advance.
Right.
Because even if we have state changing working, we still need to make sure that there is some mechanism that causes the level to advance. Otherwise, all the cells will disappear and you'll be left on the empty game board forever.
Exactly. And then with all of this, it really does feel like at this point we've got a fully playable, functioning game. And we do. But we need scores, and we need some sort of heads-up display letting us know how many lives do we have left, what is our current score, what are the cells' value, and of course, Well, I guess I'll talk more about the time power-up in a minute because we haven't yet got to that. But we need scores and all. So let's go ahead and put part 11 in.
Right, because the gameplay is actually a little bit confusing at that point. Since you can die, we'll have the 3 lives implemented, but nothing shows your remaining lives. So every time you die, it feels like more of a guess as to whether or not it's the last life.
Right.
So along with score, we want to turn right around and show everything that we need in the HUD. That would include the lives, the score value, the worth of each living cell, as well as the actual score itself. So we'll display those 3 things as a small HUD display in the upper left-hand corner of the screen.
So we'll get it drawing. Okay, so at this point, we do indeed have a fully functioning game. All game states are working right. The player is working right. The cells are working right. The enemies are working right. We have a score. Our lives are diminishing. The game can end. We can restart the game. Everything's in place. With that, this is going to allow us to move into the last 2 parts, which is where we're going to focus on, I guess you can say, an enhancement for the game, where we're going to set up a very generic power-up class, and then we'll use that power-up class for creating a very specific power-up, the time power-up. So let me go ahead and throw in a new screen real quick. And we'll come up here with part 12. And in part 12, we're going to implement that very generic power-up class.
Because as simple as a power-up may seem, there's actually quite a few things, especially timing related, that we need to take into account. Since the requirement for the power-ups were that they, 1, have a delayed spawn, so they don't appear immediately on game start. Then there's actually another delay, and that is once the power-up is picked up, it has a limited amount of time that it is in effect for. That time expires, and then its spawn time has to expire, and then it can respawn, and then the cycle begins over. So there's a lot of timing-relating things we need to address.
Exactly.
Also, we can go in and put a display of a bar class, so that since the power-up has a limited amount of time for which it works, we'll put a bar up on screen as a HUD element so that we can get a visual representation of how much time we have left.
Okay. And once we have that set up where we can draw from it, what we're going to do then is go ahead and create, in the final part 13 here, create the time power-up. But starting that out, what we're going to do first is come up with some sort of way to slow down game time. That's really important. We need some sort of mechanism that will allow us to slow everything down in the game with the exception of us. Then we can create the time power-up and implement the time power-up, where the time power-up can then utilize that means of slowing down game time.
Right, before a time power-up could be useful, we need some easy mechanism that can be used to adjust the game speed. And this is going to require going through a lot of the time-based code throughout the game and adding an additional level of control so that the speed can easily be controlled. In the end, what would be desirable is to have a single property somewhere, maybe back up an actor, whereby we can control the overall speed just by setting something. To have a speed control value where if we set to 0.5, everything would run at half speed.
Right.
And the nice thing about having this available is then we can turn around and create a time power-up, and that time power-up has a very simple switch it can throw to make the game slow and then fast again, so that the actual code within the time power-up can be very simple. It will just utilize that layer of control that we put into the game.
So we'll create it, and then we'll implement it.
And we'll turn around and do the creation and implementation at pretty much back-to-back, simply because there isn't a lot of code that has to be added to the time power-up. Since the power-up related code is handled in the generic power-up, and the speed code has already been implemented into the game, it just needs to combine those two things so that the game slows down and speeds up.
That's right. And then at that point, we're done. So then all that's left is test, test, and test. Get your buddies to test your game. Get your family members to test your game. You are the first defense for bugs, but you're also the weakest defense. And here's why. The game's going to play the way you designed the game to play, and you're going to play it the way you designed it.
Right. You will design something to be used a certain way, and because you know that, you'll test it that way.
That's right.
So someone else doesn't understand how the game is to work, so they might break it in ways that you haven't even thought of.
That's right. So it is very important to bring other people in to help test out your game. So that's pretty much it. Once again, this has been a very broad overview of our implementation plan. And what we're going to do is start getting into each of these different parts, and we'll break them down on whiteboard, then we'll advance into coding out that part. The idea, once again, is to keep us very focused on exactly what is taking place in the coding phase. We don't want anybody to get left behind here. Very important. Logan, is there anything else that you want to add into this overview?
Nothing comes to mind. Following this process should result not only having the game, but in a way that we don't get lost in. Well,
all right, so the question is, how much writing have we done? Dun, dun, dun. Because I'm starting to feel the pain in the hand. Oh, okay, went back one too far. Hey, we've done pretty good. All right, so with that, ladies and gentlemen, that will wrap things up, and let's go ahead and move over into part 1 of the real implementation plan.